Onions are harvested at full maturity using large-scale machinery designed for continuous, high-volume agricultural production. Undercutting blades loosen soil precisely, allowing onions to be lifted without bruising or rupturing outer skins.
Harvested onions are transferred immediately into bulk trailers for rapid movement off the field.
Once loaded, onions move immediately into controlled industrial supply chains for processing. Bulk onions arrive at processing plants, where controlled unloading begins the industrial conversion process.
Sieving systems regulate flow, separating stones and debris before onions enter enclosed processing lines.
Optical inspection systems remove damaged bulbs, protecting equipment and ensuring consistent processing quality.
From storage, onions move in controlled batches toward washing and decontamination stages.
Industrial washing begins with rotating drums that mechanically remove soil using water, motion, and controlled residence time.
Pressurized spray systems reduce surface contamination and microbial load before further processing.
Wash water is filtered and recycled, maintaining hygiene while reducing industrial water consumption. Dewatering conveyors remove surface moisture, preparing onions for mechanical peeling operations.
Cleaned onions exit washing under controlled conditions, preventing recontamination before peeling.
Peeling begins using abrasive drums that mechanically remove outer skins at controlled rotational speeds.
Friction and controlled dwell time detach dry outer layers without cutting into usable onion flesh.
Compressed air systems remove residual skins, ensuring uniform peeling before trimming stages.
Automated trimming removes roots and tops, standardizing onion geometry for downstream slicing.
Optical inspection verifies peeling quality, preventing defects from entering dehydration equipment.
Prepared onions advance in sealed systems, maintaining hygiene before high-speed slicing operations.
Slicing lines reduce whole onions into uniform sections, preparing material for controlled dehydration. Blade geometry and feed speed determine slice thickness, directly influencing drying rate and final texture.
Uniform slices expose internal moisture evenly, enabling predictable heat and mass transfer during drying.
Even conveyor loading prevents overlap, ensuring consistent dehydration across the entire product stream.
Enclosed transfer systems protect sliced onions from contamination before thermal processing begins.
Routine blade inspection maintains slice accuracy and prevents downstream process instability.
Dehydration begins in continuous belt dryers, where controlled heat removes moisture from onion slices.
Air temperature and velocity are staged to evaporate moisture without cooking or scorching the product.
Moisture migrates from the onion interior to the surface, driven by heat and vapor pressure gradients.
Indirect heat exchangers supply stable thermal energy while isolating product from combustion gases.
Exhaust humidity control maintains drying efficiency and prevents overdrying or case hardening.
At dryer exit, onion moisture is reduced to stable levels suitable for long-term storage and milling.
After dehydration, onion flakes must be cooled gradually to prevent condensation and structural damage.
Controlled airflow removes residual heat while maintaining flake integrity and minimizing breakage.
Rapid cooling is avoided to prevent moisture condensation and microbial risk.
Filtered cooling air protects product purity while stabilizing final moisture distribution.
Once stabilized, cooled flakes are buffered to synchronize downstream milling operations.
Temperature-stable flakes move forward under sealed conditions, ready for size reduction into powder. Dried onion flakes are reduced to powder using high-energy mills designed for continuous food-grade operation. Impact and shear forces fracture brittle flakes, controlling particle size through screen geometry.
Pin mills refine powder texture by applying precise shear without excessive heat generation.
Dust control systems protect workers and equipment while maintaining sanitary milling conditions.
Air classification ensures uniform particle size, recycling coarse material for reprocessing.
Finished powder is collected under sealed conditions to preserve quality before testing.
Quality control begins with systematic sampling to verify powder safety, consistency, and compliance. Moisture testing confirms dehydration targets, preventing spoilage and ensuring shelf stability.
Microbial analysis verifies that drying and handling eliminated contamination risks.
Metal detection safeguards against equipment wear debris entering finished food products.
Particle size verification ensures consistent flavor dispersion and predictable downstream performance. Only approved batches proceed forward, maintaining industrial food safety and traceability standards.
Approved onion powder enters automated packaging lines designed for accuracy, hygiene, and high throughput.
Nitrogen flushing displaces oxygen, extending shelf life and preventing oxidation of flavor compounds. Bulk packaging supports industrial customers requiring large volume ingredient supply. Robotic palletizing increases consistency, stability, and worker safety in final handling stages. Controlled storage preserves product quality while enabling full batch traceability. Finished onion powder enters global logistics networks, completing the industrial transformation from raw crop to ingredient.